Hi everyone, welcome back to your physics class. In a previous lesson, we studied the types of mirror, flat mirror and spherical mirror. In a flat mirror, the image created by flat mirror is always virtual image, upright, same size, same height, and the image distance is equal to object distance. In the second type of the mirror, spherical mirror, if you remember, we said that we have two different types of spherical mirror, concave spherical mirror and convex spherical mirror. So yesterday in a previous lesson we focused on a concave spherical mirror. In concave spherical mirror, the image sometimes virtual and sometimes real image. It depends on the position of the object. So if you remember, we had 6 configurations of the concave mirror. Sometimes the image virtual and sometimes is real image. For the real image, the image always inverted. But for virtual image in concave mirror, the image is always upright and magnified. Today's lesson, we're going to talk about the convex, the second type of spherical mirror, which is convex spherical mirror. This is the second type of spherical mirror. Convex spherical mirror, a mirror whose reflecting surface is outward curved segment of a sphere. Like, for example, assume that this is principal axis, convex spherical mirror, convex spherical mirror. In convex spherical mirror, whose reflecting surface is outward. Okay, this is back of the mirror or behind the mirror. The object must be placed here. This is object. Okay, the object is usually should be placed in the front of the mirror. Here is front of mirror. And this side is back of the mirror or behind mirror. Guys, if we complete this curve, if we trace this curve, you know that the center of the circle is located behind the mirror. The center of the circle, center of curvature, in convex spherical mirror, guys, listen carefully. In convex spherical mirror, center of curvature located behind of the mirror. But in concave, the center of curvature located in the front of the mirror. And the distance from center of curvature to the surface of the mirror is called radius of curvature. And we have another point which is called focal point. So the focal point is located between the mirror and the center of curvature. So the distance between the surface of the mirror and focal point is called focal length. What is focal length? Is the distance between focal point and the surface of the mirror. Guys, look, in convex spherical mirror, pay close attention please. Both radius of curvature and focal length located behind of the mirror. Located out here behind of the mirror. So that is why both of them consider it to be negative. Our radius of curvature is negative, focal length also negative. Why? Because they are located behind of the mirror. In convex spherical mirror, we have only one configuration. We have one image. Okay, it's not like a concave mirror. In concave spherical mirror, we have 6 different types of image. But in convex, we have only one image. So the image in convex, the properties of the image is constant. Okay, always reduced, real image, upright, located behind of the mirror. The image is always located behind the mirror, so that is why Q also negative. So in convex spherical mirror, focal length negative, radius of curvature negative, image distance negative. Why? Because all of them located behind the mirror. Look at this simulation about the convex. Guys, look. This is convex spherical mirror. Okay, the type of the mirror is what? Convex. This one is concave. This one is flat mirror, but this one is convex spherical mirror. Okay, the type of the mirror is convex spherical mirror. Okay, guys, look. This is object and this is image. In convex spherical mirror, we have only one image. We have only one configuration. So it doesn't matter the object placed at where. It doesn't matter the object is close to the mirror or away from the mirror. In all cases, we have only one image, and the image is what is reduced compared with the object. The image is smaller. It means that a magnification less than 1, and the image is A virtual image. Why this is virtual image? Because located behind the mirror. This is behind of the mirror, this side, and this side is the front of the mirror. The image is upright, smaller, and virtual. Why? Because located behind the mirror. So it doesn't matter the object near the mirror or away from the mirror. At any point on the principal axis, there will be only one image, and the image always has constant properties. So the properties of the image that created by convex spherical mirror, always image is virtual image, smaller, upright. Okay. So why use convex mirrors in cars? In car, the convex spherical mirror can be used because the curved shape lets you to see more area than a flat mirror. Okay? So the type of the mirror in the car is convex spherical mirror. Why? What is the reason? Why we are using convex spherical mirror in car? Because the curved shape, it means that the convex spherical mirror lets you see what? More area. More area. But it makes things look smaller. The image is reduced smaller and further away than really are. So that is why does not depend on this mirror for the distance and the shape and the size. Okay? Sorry, not shape, size only. That's why these mirrors often say object in mirror are closer than appear. Okay? How does it work? The mirror reflects light in a way that makes it look like the image is coming from behind the mirror, but actually it's not coming because the image is virtual. The properties of the image in convex. In convex, the properties of the image created by convex spherical mirror, always virtual image, not real, cannot be projected on the screen, and Q is negative, always in convex. The image is upright, not upside down. M is positive. Smaller than the actual object, magnification less than 1. Image located behind the mirror. The image formed by convex mirror is also upright and virtual. So R, F, Q, R negative, focal length negative, Q negative. Sorry, this is not positive, this is negative, make it negative. Okay? H prime is positive because the image is upright. Types of the mirror and convex mirror. Object distance always positive in both types, concave and convex. In both types, P is positive. Image distance in convex is negative. Focal length, negative. Radius of curvature, negative. Image is height, positive. Magnification, positive. What does the positive sign indicate for magnification? It means that the image is upright, always. The image is upright. Look at sample problem 5C. Guys, look. The sample problem 5C says an upright pencil, this is object, is placed in the front of convex spherical mirror. What is the type of the mirror? Convex. Whenever you see convex, write down F negative, R negative, Q also negative, M is positive. The focal length is 8 centimeter. F is equal to negative 8. Why? Because this is convex spherical mirror. In convex, focal length located behind the mirror. An erect image 2.5 centimeter tall. This is H prime, the height of the image. An erect image, it means that the image is height 2.5 centimeter tall. This is H prime, 2.5 centimeter. Format, the image format at 4.44 centimeter. Q is equal to, don't forget the negative, guys, be careful. Negative 4.44 centimeter because this is convex. Behind the mirror, it means that the image is virtual. Find the position of the object, P. What is unknown? The position of the object and the magnification of the image, M. And the height of the pencil, height of the object, H, without prime. Okay? So we have 3 unknowns. Now we're going to find one by one. For the first one, P, how can we determine P? 1 over P is equal to 1 over F minus 1 over Q. 1 over P, focal length, 1 over negative 8 minus 1 over negative 4.44. Negative with negative becomes positive. 1 over P is equal to what by calculator? Guys, look. 1 over negative 8. Guys, negative times negative, it's going to be positive. Plus 1 over 4.44 is equal to 0 point something, and 1 divided by answer or flip, it's going to be 10. Okay, so 1 over P is equal to 0.1. If you flip both sides, P is equal to what? 1 over 0.1, which is equal to 10 centimeter. P is equal to what? 10 centimeter. For magnification, M is equal to what? Negative Q over P. This is the negative of the equation, guys. Okay? And also the Q is also negative. Already Q is negative. Negative 4.44. Okay? Don't say I'm not going to write negative because we have negative. This negative is different from this one. This is the negative of the equation, but this one is negative of Q. Divide by what? By 10. Negative times negative, positive. 4.44 divided by 10 is equal to positive 0.44. So the positive sign indicates the image is upright. 0.44 image is smaller. Image is what? Is smaller. The last one, determine what? The object's height. Object's height, h, should be bigger than h prime, always. How can you determine h? In which equation we have h? In equation of magnification. H prime over what? Over h. If you rearrange this equation, h is equal to what? It's going to be h prime over m. H prime was given 2.5. M, we didn't have M, but we found 0.44, which is equal to 5.6 centimeter. So 5.6 centimeter is bigger than 2.5. Guys, is this image real or virtual? It should be virtual. Why? Because located behind the mirror, Q is negative. Is this image upright or invert? Upright. Why? Because the sign of M is positive. Is this image smaller or magnified? Smaller, because less than 1. 0.44 less than 1. Object is height bigger than image is height in convex? Yes, always. This is sample problem 5C. The image is upright, virtual, and smaller. Practice 5C question 1. The image of crayon appears to be 23 centimeter. This is Q. The image distance, question 1. Q is equal to negative 23. Okay, but we don't know this is convex or concave. Behind the surface of the convex, what is the type of the mirror? Is convex. So that is why this Q, it should be what? Negative 23 centimeter. Okay, and is 1.7 centimeter tall. The image's height, H prime, 1.7 centimeter tall. If the mirror's focal length, 46 centimeter, F, negative 46 centimeter. How far in the front of the mirror is the crayon positioned? Crayon, it means that the object is position, object is distance. P. The object's position is unknown. P. Okay, object distance. What is the magnification? M. And is the image virtual or real? Image is virtual. Why? Because we have convex mirror. The image is negative Q, located behind. Is the image inverted or upright? It should be upright. How tall is the actual crayon? H. Again, we have 3 unknowns, exactly the same question as we solved it in sample problem. 1 over P is equal to 1 over F minus 1 over Q, 1 over negative 46 minus 1 over negative 23. So 1 over P is equal to, let's do by calculator, 1 divided by negative 46. Minus 1 over negative 23, which is equal to 1 over 46. You have to flip both sides to determine P, not 1 over P. P is equal to what? 46 centimeter. P is equal to what? 46. M is equal to what? Negative Q over P. Negative, sorry, This is the negative of the equation. Q already has a negative sign. Negative with negative becomes positive. Divide by 46. M is equal to what? Positive. Positive what? 0.5. The image is upright. Why? Because M is positive. The image is smaller. Why? Because 0.5 less than 1. The image is virtual. Why? Because we have convex mirror. Q is negative. Okay. And how tall is the actual crayon? H. We have to find H. How can we determine H? By using the equation of magnification. H prime over H. So H is equal to what? H prime over M. 1.7 divided by 0.5, which is equal to 3.4. So H is bigger than H prime in convex spherical mirror. It's very easy, and you can find object distance, magnification, and the object's height by using the equation of the convex spherical mirror. Question 2, a convex mirror with the focal length. Question 2, focal, because we have convex, focal length is negative 0.25 meter, performance 0.08 meter tall image, H prime 0.08 meter of an automobile at a distance 0.24 meter. This is P, the object is distance 0.24 meter distance. Okay, sorry, a convex with a focal length, this is focal length, yeah. The image of an automobile, sorry, this is image, Q is equal to what? The image of the automobile is equal to 0.24. This is Q is negative, it should be negative. Okay, negative 0.24 meter. What is the magnification of the image? M is unknown. And where is the car located? P. And what is the height of the object, car? H. Is the image real or virtual? Virtual. Why? Because we have convex. Is the image upright or invert? Upright. Why? Because we have convex. Okay? Now, let's find magnification. But before magnification, we have to find P, because without P, we cannot find M. P is equal to what? 1 over P, 1 over F, minus 1 over Q, 1 over negative 0.25, minus 1 over negative 0.24, 1 over P is equal to what? 1 divided by negative 0.25 minus 1 divided by negative 0.24. I got 1 over 6. P is equal to what? P is equal to 6 meter. Okay, P is located at 6 meter, so here it should be 6 meter. This is P. Magnification is equal to what? Negative Q over P. Negative 0.24 divided by 6. M is equal to Q over P. Yes, P is equal to 6 centimeter is equal to 0.24 divided by 6 is equal to 0.04, positive 0.04, unitless, has no unit. Okay, this is upright and smaller. Height is equal to what? Magnification H prime over H. H is equal to what? H prime over M. H prime was given 0.08 divided by 0.04. Divide by answer, I got 2. So H is equal to 2 meter. Okay, this is the actual height of the automobile, which is equal to 2 meter. Question 3. Question 3, a convex mirror of focal length. Again, we have convex focal length F. This is question 3. F is equal to negative 33 centimeter. Forms an image of a soda bottle at a distance of 19 centimeter. The image is equal to negative 19 centimeter behind the mirror, which is Q is negative. If the height of the image, H prime, is equal to 7 centimeter, where is the object located? P is unknown. What is unknown? P. And how tall is it? H. And what is the magnification? A. This the same thing. Okay, you have to do the same. 1 over P, 1 over F, minus 1 over Q, 1 over F, negative 33, 1 over negative 90, 1 over P is equal to what? Is equal to 1 divided by negative 33 minus 1 divided by negative 19, which is equal to 14.620. Flip both sides. P is equal to what? 1 divided by answer is equal to 44. P is equal to 44.8 centimeter. This is the object's distance. Okay. The magnification the second one is the magnification of the image. M is equal to negative Q over P, negative Q, negative 19 divided by 44.8. M is equal to what? 19 divided by answer. I got 0.42, positive 0.42 unit less. So the object is height. The object is height. H is equal to what? Is equal to H prime over M. H prime 7, M 0.42. 7 divided by 0.42 is equal to 16.5 centimeter. This is the object's height. Question 3. Okay, guys, look. Question 4, a convex mirror with a radius of curvature. Look at this question. Question 4. Question 4, we have radius of curvature. R is equal to what? Because we have convex spherical mirror. This is convex. Radius of curvature, it should be negative 0.55. Okay? Is placed above the easels in a store. Determine the image distance and magnification of the customer. Image distance, Q, and the magnification, M, lying on the floor, 3.1 meter below the mirror. Okay, the image distance and magnification of the customer line on 3R. This is P, object distance. 3.1 meter below the mirror. Is the image virtual or real? The image is virtual because it's convex. Is the image inverted or upright? Okay, so let's find Q and magnification. Guys, look. Because we have radius of curvature, we can find focal length. Focal length is equal to what? Focal length is equal to R divided by 2. Okay. Okay, guys. Because radius of curvature was given negative 0.55, as you know, there is a relation between focal length and radius of curvature. Focal length is equal to radius of curvature divided by 2. Because focal length is smaller than radius of curvature. Radius of curvature is equal to what? Twice of the focal length. Okay. Now, focal length is equal to what? Negative 0.55 divided by 2. Okay. 0.55 divided by 2 is equal to, focal length is equal to negative 0.275 centimeter. Centimeter or meter? Meter, sorry. Okay. All quantity must have the same unit, guys. Be careful. Okay. It's okay if you solve the question with the centimeter or meter. It doesn't matter. Okay. But it's not allowed. Like F is meter, Q is centimeter. Okay. So you have to make the same unit, all of them. Okay. Now, how can we determine Q? Q is equal to what? 1 over Q is equal to 1 over F minus 1 over P. Replace. F we didn't have, but we found with the relation of the radius of curvature, okay? 0.275 minus P was given 3.1, okay? Is equal to what? Guys, look, 1 divided by negative 0.275 minus 1 divided by 3.1, which is equal to Q is equal to what? 1 divided by answer. I got negative 0.25. Negative 0.25 meter. Q is negative. Okay? Q is equal to what? Negative 0.25 meter. Okay, Q is equal to negative 0.25. Now let's find M, magnification. The magnification M is equal to negative Q over P. Negative of the equation, negative of Q divided by 3.1, which is equal to positive 0.08. The image is upright because the sign of M is positive and smaller. This is question 4, very good question. Question 5, guys, look. A spherical glass ornament, so this is considered to be a convex. Spherical glass ornament is 6 centimeter in diameter. So we have diameter in this question, question 5. Guys, look. The diameter is the entire distance from this side of the circle to the other side. This is diameter, okay? Half of diameter is the center of curvature. Half of center of curvature is the focal point, okay? So how can we determine radius of curvature? Diameter divided by 2. Here diameter is 6 centimeters. 6 divided by 2 is equal to 3 centimeters. So in this case, radius of curvature is equal to what? Negative 3 centimeters. And the focal length is equal to what? Focal length is equal to negative 1.5 centimeter. Okay? And now in this question we have both radius of curvature and the focal length is equal to negative 1.5 centimeter. Whenever the diameter is given, you can find radius of curvature and the focal length. Okay? How can we determine radius of curvature when diameter is given? The diameter divided by 2 is going to be a radius of curvature. If an object placed at 10.5 centimeter, P is equal to 10.5 centimeter away from the ornament, where will its image form? Q is unknown. What is unknown? Q. What is the magnification? M. Is the image virtual or real? The image is virtual because it's convex. Is the image inverted or upright? The image is upright. The spherical glass ornament considered to be a convex. Guys, be careful, okay? So how can we determine Q? 1 over Q is equal to 1 over F minus 1 over P. Do we have F? We didn't have, but we found negative 1.5 minus P was given 10.5. Q is equal to what? Q is equal to 1 divided by negative 1.5 minus 1 divided by 10.5, which is equal to this number, 1 divided by answer. Guys, I got negative 131 centimeter. 1.31 centimeter. 1.31 centimeter. Magnification, it's very easy, is equal to negative Q over P. Q negative 131 divided by P 10.5, which is equal to 0.125 positive. 0.125. The image is upright, reduced, and virtual. This is question 5. The last question, question number 6 in convex spherical mirror. A candle is 49 centimeter in front of the convex. The type of the mirror is convex. P is equal to 49 centimeter, okay, in front of a convex spherical mirror that has the focal length 35, F negative 35. Why? Because convex focal length is negative. In convex spherical mirror, focal length is negative. What are the image distance and magnification? Image distance and magnification. Okay. Is the image virtual or real? Virtual, because we have convex. Is the image inverted or upright? Because we have convex. Okay. It's very easy. 1 over Q, 1 over F, minus 1 over P, 1 over negative 35, 1 over 49. Q is equal to what? Q is equal to 1 divided by negative 35. Sorry. Minus 1 divided by 49. 1 divided by answer. Guys, I got negative 20. Negative 20 centimeter. This is Q. Okay. Magnification. Negative Q over P. Negative 20 divided by 49 is equal to, magnification is equal to positive 0.42. This is the magnification of this image that's created by the convex spherical mirror. Guys, we finished this sections, and also we solved all questions about the convex spherical mirror. Now let's talk about the parabolic mirrors. It's very easy. What is parabolic mirrors? A parabolic mirror is a curved mirror, okay, shaped like a parabola. So that's why we call parabolic mirror. It is designed to what? To reflect all parallel incoming rays like a light from a distant star. So they meet at a single point called the focal point. In parabolic mirror, guys, parabolic mirror, it's a curved mirror like this, like concave mirror, but it has more bend. Okay, so this is incoming light, reflected light. Incoming light, reflected light. Incoming, reflected. All reflected light are focused and intersected at focal point. In parabolic mirror, guys, in parabolic mirror, all the reflected light, they intersect exactly at one point. This point is called focal point. Okay, all the reflected light, they intersect at a focal point. This is parabolic mirror, as you can see in this figure. What is the problem with the normal or the parabolic mirror, with the spherical mirror? Sometimes when the light rays hit the spherical mirror, rays that comes in the parallel mirrors do not all meet at one single point. This creates what? A blurry image. Whenever the reflected light does not intersect exactly at one point, the image will be blurry, okay, and not very clear. This phenomenon is called spherical aberration. So what is the spherical aberration? The spherical aberration is a problem with the spherical mirror when the reflected light do not intersect exactly at one point. So this is spherical aberration. Look, spherical aberration. Spherical, yeah, aberration. This is incoming light, reflected light. Incoming light, reflected light. Guys, look. The reflected light, they do not intersect exactly at one point. They do not intersect exactly at one point. This phenomenon is called the spherical aberration. In the spherical aberration, the image is blurry, not very clear image. So we have to fix and treat this problem by using parabolic mirror. Okay. Think of it like a group of arrows being shot at a target, but not all hitting the same bullseye. The spherical aberration, what is spherical aberration? Is a problem that happens when light rays hitting a spherical mirror, but do not all focus at the same point. As a result, the image is blurry image or unclear. It happens because rays far from the center of the mirror behind so bend differently than the rays near the center. So how do parabolic mirror fix spherical aberration? By using parabolic mirrors. Has special curved shape like a satellite dish and reflects all parallel rays to a single point called the focal point. This gives a clear image without distortion. Okay. Telescope. What is telescope? Is a device used to see faraway objects more clear by collecting and focusing light or other forms of electromagnetic radiation. This is what? This is telescope. Use it to what? See faraway object like planets and stars. We have two different types of telescope. Refracting telescope and reflecting telescope. In refracting telescope uses lens, but in reflecting telescope uses curved mirror. What is the difference between refracting telescope and reflecting telescope? In refracting telescope uses what? Lens. To what? To bend light and forms an image. Light pass through the lens. Okay? These were the first type of the telescope. But reflecting use curved mirror instead of a lens. The mirror reflects, not refracts light from the image. Okay? Also use small lenses to help magnify the image common in modern astronomy. Okay? That's all for today, guys. We finished chapter 5. Inshallah, in the next lesson, I'm going to explain chapter 6 about the refraction of light. Keep an eye on my YouTube channel, and thank you for listening.